of the prostaglandin D2 system in the central and the peripheral nervous system. So this is my favorite small molecule, prostaglandin D2. That is one of the most potent endogenous sleep-promoting substance, and also acts as a very powerful inflammatory mediator, actively produced by mast cells and activated T helper 2 cells. And also, as shown here, there's so many, it acts as a modulator of several physiological functions, including genital development, appetite, and so many different functions they have. And there are two distinct types of PGD, prostaglandin D synthase, that we know it. The light one is the, this is, no? How to do that? Okay. So this one is the, we named lipocarin type PGD synthase. That we sometimes use the L-type enzyme that is mainly involved in the production of endogenous sleep substances and also genital differentiation and also cardiovascular regulation. On the other hand, right one is hematopoietic PGD synthase that is mainly involved in inflammation and localized in muscle cells, microglial cells, and also activated T helper 2 cells. And also there are two distinct types of the prostaglandin D2 receptor. Both are G protein coupled 7 transmembrane receptors, but the coupling G protein is different. DP1 receptor is coupled to G alpha S and coupled to the increase in cyclic intracellular cyclic MP. And this receptor is a homologous receptor of other prostaglandin receptors like PGE2 or F2 alpha, the thromboxane, or PGI2. On the other hand, DP2 receptor, that is sometimes people know as the CRTH2 receptor, that is a chemoactant receptor homolog on T helper 2 cells receptor, or O1 receptor GPR44, all are the same receptors. That is coupled to the G alpha I, and also suppressing the intracellular cyclic MP. And this receptor is a member of the chemoattractant homologs, like FMP receptors, and localizing T help several immune response cells. And combination of two different syntheses and two different receptors. So prostaglandin D2 involved in the various different functions. For example, I listed in my abstract, and I found that some of the references already drop out in the printing out. So please try to pick up some references. So all these data, LPGDS DP1 system is involved in regulation of sleep, and also LPGDS DP2 receptor system is also involved in the mediation of Schwann cells. All those are already published in last year. So my family name is very unique, so you can easily find my references. So try to read my previous publication. And also HPGDS DP1 system is in the brain is very important for the suppression of epilepsy. That is also last year published in Experimental Neurology. And LPGDS is also the same protein as the beta trace protein. That is a major protein of human cerebrospinal fluid. And also it means that this enzyme is also secreted out to the cerebrospinal fluid and also acts as a several, how should I say, carrier transporter of the hydrophobic substances. And recently, our collaborator found that is the LPGDS or beta trace concentration in human cerebrospinal fluid is upregulated in after subarachnoid hemorrhages, and several days after the hemorrhages, that CSS coupled to the very green chromophore. That was finally identified as biliverdin. It's a harmful degradation product. Therefore, So LPGDS beta trace protein also acts as a scavenging protein to removing out a very harmful hydrophobic toxic substances. And the HPGDS and also DP1 and 2 system is also very important for acceleration, abrogation of the inflammation, and also in the neuroinflammation and also muscular inflammation. And the topic is in point, especially in point of therapeutic point of view. I want to introduce this very hot topic. Is still unpublished data, but anyway, it's a very important data. So final conclusion is that is orphan drug development for Duchenne muscular dystrophy. So Duchenne muscular dystrophy, as some of you already know it, is a genetic defect caused by the mutation of dystrophin gene. And the most severe and most common type of muscular dystrophy. So this is caused by the genetic mutation. That means that even now is no cure at all. So when the boys are young, that is also okay. But when they become to the 4 years old, his body weight is going up. Then this mass is very weak because lack of the functional dystrophin protein. Therefore, the year by year, mass was reducing, muscle mass was reducing. And when they became to the last year of the junior school is 10 or 11 years old, most people have to use the wheeling chair. After that, it's still year by year, the muscle was decreasing. Therefore, when they become to the 20 years old, respiration is very difficult. Therefore, people have to use artificial respirators. And using those aspirators, so maybe 10 or 20 years, but longer life is proved, but no other choices. So they almost 30 years ago, so one doctor co-student of Department of Pediatrics of nearby our previous institute, they very accidentally found that is one of my target enzyme, hematopoietic PGD synthase, is upregulated in the necrotic zone of DMD patient. And it means that is the processing of the DMD symptom, probably muscular inflammation, probably mediated by prostaglandin D2, that is produced by hematopoietic PGD synthase, is occurred in this symptom. Then I decided to develop the inhibitor to stop the function of this enzyme. And also, I was a biochemist. I tried to determine the three-dimensional structures of this enzyme by crystallography. And the original one is the rat enzyme. Then several years later, we determined human enzyme. And also, very fortunately, we found this very early lead compound of the HPGDS inhibitor that is already available one. That's code name is HQL79. And we determine complex structure of the enzyme and these early lead inhibitors. And also, now we know that this early lead compound is inserted in this very severe cleft structure of this enzyme. And this enzyme absolutely required glutathione for the reaction. Therefore, it means that probably here is a catalytic cleft. And now we know that the size and depth and shape of this catalytic pocket, we can design a much more higher affinity chemicals. And very, very recently, not so very recently, but anyway, 2011 is also the next generation of the inhibitor, TFC007, is we design and also determine the tertiary structures. And the resolution is, original one is 2.3 angstrom, but very recently almost near to the 1 angstrom resolution. To make this high quality X-ray crystallography, we use a microgravity condition. That is, we use the internal National Space Stations. We launched our protein and inhibitor solution, and launch through the Progress vehicle from Baikonur Space Center of Kazakhstan, and stay in the solution in ISS for several months. And under microgravity condition, we slowly generated high-quality crystal. Then when astronauts return back using the Soyuz vehicle, they bring back our sample on the Earth. And we can carry that sample to the very big synchrotron facility in Japan. This is a super photon ring, 8 giga-electron volt. This one is generated highest powerful X-ray generated on the Earth. Anyway, by using this powerful X-ray, we can determine the very, very fine structures. And also, when I showed the crystal of our enzyme growing on ground or in space, see, on the ground-grown crystal, you can see several crystals, but the shape is slightly different. And also, even in the big size, you can see that somehow this crack in there. That means that it's not so single crystal, it's somehow mosaic crystal. On the other hand, on the space-grown crystal is very, how should I say, uniform, and very, the mosaicity is very low. And therefore, we can get a very, very ordered structure by using powerful X-ray generators. And here, so for example, ground crystal case is 1.9 angstrom. So I showed this is the electron density map of the very important tyrosine residue. So tyrosine residue containing the benzene structure. But at CC 1.9 angstrom resolution, you can see it in any hole. So benzene ring is just like a plate. But once the resolution is almost linear, near to the 1 angstrom case, so you can see that each carbon atom is almost isolated, and also the hydrogen atom is slightly bigger than carbon atom. And also, see, very small electron density here, that red one, that is the hydrogen atom. So when I was a student, is the X-ray crystallography can identify position of the carbon, nitrogen, and oxygen. But hydrogen is impossible because size is too small. But in fact, now it's okay. So young generation, you are lucky, see? And anyway, so from this early lead compound, we designed much more stronger inhibitors complex. And within several years, its potency is almost several hundredfold, quickly going up. And after that, we modify these structures, much more stable for toxicity and also the bioavailability. And finally, these two compounds are almost near to the clinical trial. And then we use some of the inhibitor to check the efficacy of the really this HPC inhibitor is effective to slow down the progress of the DMD. So we used DMD beagles. These two is the same litter made, both lack the dystrophin gene. Therefore, both dogs cannot produce functional dystrophin. But here is without any normal food without any inhibitors. So in this dog, we added the food containing HPC inhibitor for almost 1 year. So this videotape clearly shows that treated dog can run a long corridor, even at 1 year old. But on the other hand, untreated vehicle try to run several meters, but it's very difficult to keep the respiration. So they suddenly stop it and also walking and finally sit down. Therefore, this is a very typical videotape, but we repeated several pairs of vehicle dog and also drug treatment and stopping the drug treatment anyway that we can confirm. If we can continuously treat it with inhibitor, so we can maintain animals' locomotive ability for a long time. And this is the prostaglandin D2. So in our body, this one is metabolized to secrete into the urine in this form. So we measured urinary metabolite concentration by LC mass. So here is a urinary content of this metabolite in normal dog. And the suddenly stop running that dog is this content. And treated dog is this content. It means that even just reduction to the half of the PGD2 production is, even though this is very effective to keep the locomotive activity. Here is the data of the DMD patient. So when we started collaboration with Japanese DMD patient group and collected the boy's urine. So when they are almost okay, these ages is urinary content is almost same as the normal boy. But so the most boys have to use the wheeling chair. Those cases, some of the boys in their body is prostaglandin D2 production is very high. Those boys has to be treated with this kind of drug. And finally, last September, so our collaborator, one Japanese pharmaceutical company, officially announced the clinical trial of this compound, TAS-205, used for the Duchenne muscular dystrophy. So almost 10 months has passed, but no negative news I listened. It means that it's no news, it means good news. Therefore, I hope is within several years that we can distribute this drug also for the patient, DMD patient in the United States and any other countries. And really, I hope so. So in the summary, so that I talk is hematopoietic PGD synthase inhibitor prevented the loss of locomotive ability of DMD beagle. And HPGS inhibitor is used for drug therapy of DMD patient. So now is that we have the hope. So it's quite different from several years ago. So therefore, if you have some family or relatives know about the DMD or muscular dystrophy, they please tell this news and give them a better hope. Okay? And thank you for kind attention.
Thanks for your speech.
Are you okay? So yeah, this videotape was very shocking one, but very impressive.